Hi guys, today we are going to be solving equations of quadratic type, or as I like to call them, quadratic-ish equations. The reason why they are equations of quadratic type is because they're not quadratic equations, they're not degree 2 equations, but they do behave like quadratic equations. They behave like quadratic equations in the sense that the first exponent is twice the second exponent. So whether we have a whole number exponents or rational exponents, if the first exponent is twice the second exponent, then we have a quadratic-like equation and we will treat it as such. So the game plan is to my original game plan was to solve each equation in two ways. The first time around by solving it directly, and the second time around is by substitution, but after thinking about it, I'm just gonna go ahead solve it directly. Sorry, we have a friend. They keep coming out during the hot weather, and I'm not gonna rewind it just for a silly ant. Okay, so let's do this. So we are asked to solve this problem. I'm gonna digress for a sec again. I'm gonna make up a side problem. So let's just say that if we had x squared minus 3x minus 10 equals 0. So kind of the same, but I switched out to like number friendly exponents. For this problem that I made up, we're like, okay, it's a degree 2 equation, so quadratic equation. Let's do this. The leading coefficient is 1, so we don't really have to use the AC method. Product of the first term should give us x, and then to complete the binomial factors, we want factors of c that add up to b, factors of negative 10 that add up to negative 3. So it's going to be 5 and 2, where the larger factor is negative. Oh, sorry for the penmanship. And then we finish it off. But what I want to point out is the following. If you can attack this problem, you can attack this one. It's just a little bit spicier. Okay, so let's do this. So first thing I want to ask myself is this: is this a quadratic-like equation? So I'm going to write quadratic-like equation. Okay, that's my made-up abbreviation for equation. You don't like it, then write it out. So is this a quadratic-like equation? So how can we tell this is a quadratic-like equation if the first exponent is twice the second exponent? So let me write it out. Is the first exponent twice the second exponent? So is the first exponent twice the second exponent? So the first exponent is 2/3. I want to know, is the first exponent twice the second exponent? The second exponent is 1/3. Last time I checked, product of 2 and 1/3 is 2/3. So to answer my question, is the first exponent twice the second exponent? It sure is, which means that this is a quadratic-like equation. So it behaves like quadratic equation. So let's go ahead solve by factoring. Hopefully it is. I mean, this is already like a spicy problem. It will be like really sad if it's not factorable, but you never know. Okay, so we have a 3-term expression. Leading coefficient is 1. Let's go ahead solve it by factoring. So let's actually let me write this over because I don't have a lot of space. So we have x to the 2/3 minus 3 times x to the 1/3 less 10 equals 0. Okay, so we have already established that it's a quadratic-like equation, so we have the green light to go to factor like we do before. Okay, so let's go ahead, throw down parentheses, focus on getting the product of the first terms. Now, when we had whole number exponents, you're just a genius. You just know that it's x times x because you're cool like that. So you either got that because you're cool like that, or you just did some cool stuff. Now, sorry for the redundancy. Now, what if your preschool friend said, how did you know it was x times x? You can't tell them like you're supposed to know, because you don't want to hurt a preschooler's friends, but you have some options. Because you want two factors, pretty much you're going to take the current exponent and divide it by 2, because you want to make groups of 2. 2 divided by 2 will give us 1. This is why we have x to the first power, or you can just copy the variable part of the middle term. No one will know. Okay, so in this case, we want two factors that multiply to x to the 2/3. You could write it down, or you can just do what we did earlier when we talked to our preschool friend. We can take 2/3 and divide it by 2. I believe that gives you 1/3, or you can just copy the variable part of the middle term. No one will know. But let's go ahead test it out, because this makes me a little bit uneasy, and then we'll check it. Product of the first terms. x to the 1/3 times x to the 1/3. If you were with me since the beginning, we had said silly exponent rules. They make me so mad. So if we have a multiplication problem, we're going to keep the base and add the exponent. So the base is x and the sum of the exponents is 2/3. A third plus a third is 2/3. So yeah, we did it correctly. Cool. So I think like we did one of the toughest part. Let's go ahead complete these two-term expression. So we want factors of c that add up to b. So factors of -10 that add up to -3, and we had said there were 5 and 2. Okay, so -5 and 2 to be exact. So we pencil it in, -5 plus 2, and the rest is history. So we are solving by factoring. So we have factor. Let's apply the zero factor property and set each factor equal to 0. So either the first factor equals 0 or the second factor equals 0. If the first factor equals 0, let's go ahead add 5 to both sides. And that will give us, my hand is in the way, but I don't know where else to put it. And that will give us x to the 1/3 is equal to 5. Fantastic. So there are different ways to go about it at this point, but you know, in my effort to break it down so many different ways, I feel like I hurt you versus help you. So I'm going to just choose one way. So one way, I have to remember that whenever I have a rational exponent, or which is code for a fraction exponent, that is code for hidden radical. So since the denominator is 3, that means that we're going to have an index of 3, or cube root of something. Cube root of what? Cube root of whatever we're left with. We're left with x to the first, so be cube root of x to the first. Of course, you don't need the 1. You can just write cube root of x. But I wanted to highlight the exponent because I don't want you thinking that we just ignore the numerator. Okay, so we have cube root of x equals 5. The reason why I like to go from exponential form to radical form is because it makes it a lot easier for me. It makes it a lot easier for me to solve it. So now that we have an explicit radical equation, I was like, okay, what are we gonna do? Okay, we use the power rule to undo the index. To undo the index of 3, let's go ahead raise both sides to the power of 3, or like in math words, we cube it. On the left side, the exponent of 3 and the index of 3 undo each other, and that will leave us with the radicand of x, and that will equal 125. Cool. Okay, so one equation down, one more to go. For the second equation, work your magic to isolate the variable term. And after you subtract 2 from both sides, that will give you x to the 1/3 equals -2. Fantastic. And then at this point, I'm just going to say the same speech. Okay, pause and rewind if you need be. Whenever you have a rational exponent, that is code for hidden radical. So I'm going to start with the denominator. Since the denominator is 3, that means that the index is 3. So that will give us cube root of whatever we're left with. And we're left with x to the first power. Okay, so we have cube root of x. And I told you why I like to put the 1. If you don't need the 1, I don't need the 1. I mean, do what you got to do. So that will leave us with cube root of x equals -2. Fantastic. So now that the radical equation has come out of its shell, let's go ahead apply the power rule to undo the index of 3. To undo the index of 3, let's go ahead raise both sides to that same power. Okay, power of 3. So on the left side, index is 3, power is 3. They undo each other, and that will leave us with the radicand of x. So we have x equals, and -2 to the 3rd power, I believe, is -8. Cool, we nailed it. Under normal circumstances, I trust our algebra, I trust our arithmetic, so I will box it and move on. But remember, whenever we have a rational exponent, that's code for a hidden radical. And when it comes to radical equations, as we talked about in the earlier unit, checking is not optional. So the question is, what if we didn't write it as a radical? You know what? Even if you had kept the rational exponent, you still have hidden radicals, so you have to check it. You don't escape it. Okay, hopefully we don't have extraneous solutions. So let's check the first answer. I have no time to by hand plug in a 125 for x, so we're gonna go ahead use our calculator. Okay, we're gonna store the 125 for x. Let's go ahead write down the equation. So we have x to the 2/3 minus 3 times x to the 1/3 less 10 equals 0. Let's go ahead take out our fun calculator. and store it. So we have 125. We're going to store it as x. So friendly reminder, how do we tell the calculator to save it? Okay, we're going to hit this STO arrow button, which is to the left of 1. So we hit it and the arrow should pop up, and you're going to store it to whatever variable you like, and we're going to store it or save it as x. So let's go ahead, store it as x. We hit enter and it has been saved. It has been recorded. So let's go ahead, enter the expression. What if you don't have a graphing calculator? Then you take a scientific calculator and then you just put 125 to the 2/3 minus 3 times 125 to the 1/3 minus 10. Then you hit enter. Okay, it's no big deal. Okay, but for those of us that have the calculator or have access to the free software from TI, let's go ahead and do this. So we have x to the 2/3. Bear in mind that I don't use the fraction button, so that's why I enter all fractions as division problems. Get out of exponent. Minus 3 times x to the 1/3. Get out of exponent. Less 10. Cool. So according to the calculator, we should get a 0. If we had done it by hand, we should have also gotten a 0. Okay, but we trust the calculator. So left side equals 0, right side equals 0. It checks out. Now, just because 125 is a solution, it doesn't mean that the other proposed solution also checks out. We're not risk takers, especially when it's very easy to check when you use your calculator. So let's go ahead, check the other solution. I'm not gonna write the equation, so I'm just gonna say that x equals -8 leads to whatever it leads to. Okay, so let's go ahead, save it or store it. So we have -8, and then you store it or save it as x. Depending on the mood that I'm in, those are the words. So it's stored. So let's go ahead, write the expression. So we have x to the 2/3 minus 3 times x to the 1/3 minus 10. Crossing my fingers, hopefully that gives me 0, so that way the left side can match the right side. I hit enter and the left side gives me 0. Equal sign 0. 0 does equal 0. So that was pretty neat. Both of these solutions checked out. So students like to box them separately, but I mean, it's fine, but I'm thinking of other sections, so just go ahead, pay attention to the word or. So just go ahead, take the union. So give one combined statement. So we want to tell the world the solutions are 125 and -8. Okay guys, so I said we're going to do 3 problems. This is our first problem. We got 2 more to go. Bear with me. Okay guys, so we're going to go ahead, continue this unit. So again, we are solving a quadratic-like equation, or my made-up words, quadratic-ish equations. We were going to solve it directly and by substitution, but I made the executive decision and just solve it directly. Cool. Let's do this. So this problem, yucky, who can solve it? Not I. Well, not right now, okay? But I know that if I had given you this problem, x squared minus x minus 6 equals 0, you're like, we got this. So this will factor to x minus 3 times x plus 2 equals 0, and then we take it from there. And if you can do this problem, you can do the one we're asked to solve. It's just a little bit spicier, so let's do this. So this is not a degree 2 equation like this bad boy right here, but I want to know, is this a quadratic-like equation? So let me just write it out. Quadratic-like equation. So how can I tell if it behaves that's just like? The reason why we say quadratic-like is because it will behave like a quadratic equation, where in this case, for the actual quadratic equation, we have that the first exponent is twice the second exponent. When we have these whole numbers, it's easier for me to ask myself, is the first exponent twice the second exponent? But when they're rational, it's not as straightforward. So I don't know. So let me write it out on paper. Is the first exponent equal to twice the second exponent? So I want to know, is the first exponent twice the second exponent? So the first exponent is 1/2. Twice, we're going to multiply by 2 the second exponent, which is 1/4. Last time I checked, product of 2 and 1/4 will give us 1/2. So to answer the question, is the first exponent twice the second exponent? Yes. So because the first exponent is twice the second exponent, then this equation will behave like a quadratic equation. So to answer the question, is this a quadratic-like equation? It sure is. Okay, so let's go ahead and rewrite the equation. So we have x to the 1/2 minus x to the 1/4 less 6 is equal to 0. We're going to solve this by factoring. There's no guarantee that should be factorable, but these problems are brutal enough that for us that we should be able to solve by factoring, unless like, oh man, I'll just bite my tongue. Okay, so let's go ahead solve by factoring. So what is the leading coefficient? The leading coefficient is 1, so that makes it a little bit less spicier. Let's go ahead, throw down parentheses and focus on getting the first term. The product of the first term should give us x to the 1/2. Again, if we didn't have the fractions, we will be winners. But just in case you were having a moment, how did you know like it was x times x? It comes from practice, but you can just be like, yeah, x times x is x squared because you're a good guesser. But if you had to talk to your preschool friend, you can just be like, well, we want 2 factors, so we'll just take this exponent and divide it by 2. 2 divided by 2 is 1. That's why we have x to the 1. Or we can just say, oh, that's easy. We just took the variable part of the middle term. Okay, doesn't matter how you digest it. Okay, so because we want 2 factors, we're going to take this exponent and divide it by 2. 1/2 divided by 2 will give us 1/4. So we're going to put x to the 1/4, x to the 1/4 in each first slot. If you're like, I have no time to divide by 2, then just go ahead, copy the variable part of the middle term. Again, no one will ever know, but you check it. Product of the first terms, you're going to keep the base at the exponents. That will give you 2/4, which reduces to 1/2. So the product of the first term has been met. To complete the 2-term expressions, we want factors of c that add up to b, factors of -6 that add up to -1. It's going to be 3 and 2, where the larger factor is negative. So we're going to put -3 plus 2. If we're solving by factoring like we are, we have factored, so we're good. So if the product equals 0, then one of these factors has to equal 0. Either the first factor equals 0 or the second factor equals 0. Alright, so if the first factor equals 0, let's take it from there. Let's go ahead, add 3 to both sides, and that will give us x to the 1/4 is equal to 3. Cool. So again, there's different ways to go about it. For me, I'm going to show you which I think a way that it's a little bit easier to digest. Whenever you have a rational exponent or a fraction exponent, that is code for undercover radical. So I'm going to start off with the denominator. So if the denominator is 4, then that means that the index is 4, and we have the 4th root of whatever we're left with. We're left with x to the first, so we're just going to put x to the first or just x. It's up to you. So the left side gives us 4th root of x equals the right side equals 3. Fantastic. So now that we explicitly have a radical equation, we're going to go ahead and apply the power rule to undo the index of 4. To undo the index of 4, you guessed it, we're going to raise both sides to the 4th power. On the left side, the index of 4 and the power of 4 undo each other, and that will leave us with the radicand of x equals whatever 3 to the 4 simplifies to, which I believe is 81. So again, under normal circumstances, I will box this and move on. But you know what? When it comes to radical equations, whether they're explicit or in hidden format, we have to check our answers to eliminate extraneous solutions. Let's go ahead and look at the next problem. So next problem, let's go ahead and isolate the x. We'll subtract 2 from both sides, and that will give us x to the 1/4 is equal to -2. Fantastic. So again, once again, we have a rational exponent, which is code for hidden radical. So since the denominator is 4, that means that the index is 4, and that will give us 4th root of whatever we're left with. In this case, it'll be 4th root of x to the first power, or just x. You write what you need to write. So same speed, you can just put pause and rewind. I'm going to say the same exact thing. To undo the index of 4, we're going to raise both sides to the 4th power. Okay, we raise both sides to the 4th power, and on the left side, index is 4, power is 4, they undo each other, and that will leave us with the radicand x equals 16. I'm going to read right back because someone's at the door. Sorry. Sorry for that interruption. Okay, so let's go ahead and do this. So where was I? So I know we nailed the algebra because you guys have my back. If I made a mistake, you would have told me. But in this case, let's look at the original equation that we have. It's above, but I typed it right here. So our equation is a hidden radical equation. Why? Because we have rational exponents. So we uncovered the hidden radical when we put it. We uncovered the hidden radical when we went from exponential form to radical form. But again, whether we have the radical symbol or not explicitly, a rational exponent is code for hidden radical. So when it comes to solving radical equations, as we did in an earlier unit, checking is not optional. So let's go ahead, check our answer to eliminate any extraneous solution. So the first solution that I'm going to check is 81. I want to know if our proposed solution is really a solution. So we have x to the 1/2 minus x to the 1/4 less 6 equals 0. And we can check it, without the use of a calculator. Substitute 81 for x, or you can even use your calculator and write 81 to the 1/2. But I don't have time for that, so we're going to do what we did earlier. We're going to store 81 for x. Let's go ahead, turn this on. We have 81, and we're going to store it as x. Enter, and then we can just enter the expression, and hopefully it equals 0. So we have x to the 1/2 minus x to the 1/4. So again, I don't use the fraction button, so I don't know where it is. So I always enter all the fractions as division problems. Minus 6, we'll hit enter, and the left side gives us 0, and looks like 0 does equal 0. Okay, so 81 is a solution. But again, just because one answer checks out, it doesn't mean that the other answer has to check out. So our other proposed solution is 16. And let's see what that will give us. So let's store 16 for the variable x. So we have 16. Let's store it as x. And let's go ahead and check it. And hopefully the left side also gives us 0. So that gives us x to the 1/2 minus x to the 1/4 minus 6. And that leads to -4 on the left side. And on the right side equals 0. So last time I checked, -4 does not equal 0. -4 only equals -4. Okay, so this doesn't check out. Okay, so what's going down? We had two possible answers. One couldn't fly. We still have something to go by. So the solution is 81. Sometimes students get a little bit nervous and they say, extraneous solution. There's no solution. It's like, no, my friends. We write no solution when you don't have a solution or a number to go by. We were going for 2, but just kidding. We only have 1. Cool. So let's go ahead, wrap up this unit. I told you that we were going to knock out 3 problems. We just did 2. Let's go ahead, do the third and final one. Okay. So we are asked to solve it. We can solve it however we like. So again, original game plan was to solve it directly and by substitution, but I made the executive decision just to solve it directly. So this is not a quadratic equation because it's not a degree 2 equation. But if it behaved like, if it was like this, then we'll be like, oh yeah, degree 2 equation. Let's do it. We solve it. So I want to know, is this a quadratic-like equation? So let me do my made up abbreviation. Okay, is this a quadratic-like equation? So how can I tell? I want to know, is the first exponent twice the second exponent? The first exponent is -2. Check it out. When we multiply that second exponent by 2, -1 times 2 is -2. So to answer the question, it is. So if it was a quadratic equation, unfortunately the leading coefficient is not 1, so I'm not gonna go straight to throwing down parentheses. We are gonna use the AC method. Okay, so let's go ahead and do this. So remember, the gist of the AC method is to split the middle term so we can have 4 terms and then factor by grouping. So let's handle it. So the corresponding x gain, we want factors of A, C that add up to B. So factors of A and C, let me go ahead, highlight A, B, C. I'm out of space, so I'll do the numbers above. Factors of A, C that add up to B. Product of A and C will give us -36. and value of b is negative 5. So we're looking for factors of negative 36 that add up to negative 5. I know there's a 9 and there's a 4, and then I lock in the signs thereafter. So the 9 and 4 where the larger factor is negative. So let's check it. Product is negative 36, sum is negative 5, we're good. So now we're going to use the sides of the x game as the coefficient of the middle term when split. The variable part of the middle term is x to the negative first. So we are going to replace this with negative 9 times x to the negative first power and positive 4 times x to the negative first power. That's like a tongue twister for me. Okay, let's do this. So that will give us 6x to the negative second, and we're replacing the middle term by these bad boys, by the sides. Negative 9x to the negative first, and 4 is positive, so plus 4x to the negative first. You bring down the rest of the equation. Cool, so let's go ahead and do this. Okay, so now that we have split the middle term, let's go ahead and factor by grouping. So we're going to group the first two, and then we're going to go ahead group the last two. From the first team, 6 and 9 have a common factor of 3, and for the variable factors, we can take out x to the negative 1. So let's do this. First term divided by GCF, 6 divided by 2 is 3. I think I said that right. Yeah, 6 divided, oh no, I said it wrong, sorry. 6 divided by 3 is 2, and the quotient of the x's, I'm going to do a thinking area. Now, if I was to really simplify this outside of this factoring, I wouldn't really divide by x to the negative first. I would divide by x to the negative second, because whoever has the smaller exponent, that's what we divide by. So if we divide by the top, x to the negative second goes into itself once, and then to the bottom, oh, I don't know, I crossed it up by mistake. Okay, let's put that in the blooper. Okay. So again, outside of this GCF stuff, let's just ignore everything to the left. I'm trying to find something to cover it. Okay, cool. Thank you, calculator. If the directions were just simplify, it will say something like simplify and fix it so we have positive exponents. Then I will look at whoever has a smaller exponent. So in this case, we will divide by the top. If we divide by x to the negative second, x to the negative second goes into itself once, and then to bottom one, we subtract that other exponent. Okay, if you have been with me, we will say silly exponent rules that make me so mad. So if we have a division problem, we keep the base and subtract the exponents. Difference of negative 1 and negative 2 will give us 1. Okay, so that will simplify to 1 over x. Okay, but for this problem, I'm going to go against my normal train of thought because of what we are doing. Okay, so in this case, I'm not really interested in I gotta make sure we have positive exponents. I'm just gonna divide by whatever is in the bottom. Why? Because that's what we're doing. We're factoring it out. So it's like the first term divided by GCF. 6 divided by 3 is 2. Now I want to know what's x to the negative second divided by x to the negative first. So let's do this. Since we're dividing by x to the negative first, x to the negative first goes into itself once, and into the top factor, silly exponent rules, they make me so mad. So if we have a division problem, we're going to keep the base and subtract the exponents. So when we divide by x to the negative first, that will give us negative 2 minus negative 1 will give us x to the negative first. Okay, so that will give us 2 times x to the negative first. Yeah, that's like a lot. Maybe this one I will do by substitution. We'll see. Cool. So second term divided by common factor, negative 9 divided by 3 is negative 3. Quotient of the variable terms, x to the negative first divided by itself will give us 1, or we say cancel. Fantastic. Okay, let's look at the second group. For the second group, the terms have a common factor of 2. Let's go ahead, factor it out, and that will leave us with first term over common factor will give you 2x to the negative first. Second term over common factor will give us negative 3. Now, the binomial factors match as expected because, and I say as expected because we took the time to make sure that our x game was correct. If these don't match, then check your x game because the x game would be wrong. So following the procedure, when it comes to factoring by grouping, we make groups of 2, take out the GCF from each group, and then we factor out the binomial expression. So that will leave us with 2 times x to the negative first minus 3, multiplied by 3 times x to the negative first plus 2. The question is, do we really have to use the AC method to factor? Of course not. If you're like, I'm a genius, I can go from here to here because I'm a really good guesser and checker, that's you, go for it. So now that we have factored, following the procedure to factor, to solve an equation by factoring, 1, we set the equation equal to 0, which already was. 2, we factor completely however we can, and then 3, we apply the zero factor property. So the zero factor property states that if a product equals 0, then one of the factors has to equal 0. So either the first factor equals 0 or the second factor equals 0. If the first factor equals 0, let's go ahead isolate this x thing. Okay, so let's go ahead add 3 to both sides. And that will leave us with, where am I? 2 times x to the negative first equals 3. Actually, no, you know what? I'm not going to isolate it. Why? Because of that negative exponent. At this point, let's go ahead and use the negative exponent rule to make the exponent positive. So flashback to many moons ago. If I have a factor and it's being raised to a negative power, to make the exponent positive, you're just going to move the factor about the other side of the fraction bar. If there's no fraction bar, then make it up. Okay, we move the factor to the other side, and anytime we move a factor to the other side, we switch out the exponent. So if we were negative, we make it positive, and it's gonna look kind of weird if we put blank over x, so we put 1 in its place. So let's go ahead and make this exponent positive by moving the factor of x to the other side of the fraction bar. So in this case, bring it down, and that will leave us with 2 over x equals 3. So it goes to show that I don't necessarily approach the equations the same exact way. Depending on how I vibe with it, that's how I'm going to attack it. So now to undo the division by x, let's go ahead and multiply both sides by x. And when we do, the quotient of x in itself will give us 1, or we say it cancels, and that will leave us with 2 is equal to 3x. For the grand finale, to isolate the x, to get rid of the times 3, let's go ahead and divide both sides by 3. And that will give us x to the 2/3. So I would check it just because I'm an overachiever, but we don't have time for that. It's not really vital that we do, because we don't have a radical equation hidden or not hidden. Okay, we don't have rational exponents. So we just hope we didn't make an arithmetic mistake. Okay, so one solution down, one more to go. For the second equation, let's go ahead isolate the variable term. And you can make this exponent positive now or later. It's really a personal choice. When we subtract 2 from both sides, that will give us 3 times x to the negative first equals negative 2. Now at this point, I'm going to go ahead and fix it so the exponent is positive. So again, we're going to apply the negative exponent rule to move the factor about the other side of the fraction bar, so that way the exponent could be positive. So the 3 stays put because we have no issue with it. 3 is not being raised to a negative power. X is, so it has to go. And then we can switch out the exponent. We went from -1 to +1. So let's do it. So the left side, bring down the rest of the problem. And now it's like, we got a fraction. So let's get rid of the fraction to get rid of the division by x, let's go ahead and multiply both sides by x. Multiplying by a variable is fine, but dividing by a variable, that's like a no-go. What do they say? No bueno. Yeah. So on the left side, quotient of x in itself will give us 1, and that will leave us with 3 is equal to -2x. Fantastic. For the grand finale, I'm crying because I see the end of this problem. To get rid of the times -2, let's go ahead divide both sides by -2. And that will give us x equals -3/2. So when we take the union, pretty much in English, give me a combined statement. We want to tell the world that the solutions are 2/3 and -3/2. So I said that we were going to do 3 problems, and this was the 3rd problem. So we're good. So remember to pause and rewind as many times as you like. Thanks, guys.